So the test is tomorrow, and you actually have this PDF copy of these like little notes that I made for you guys. It's like a cheat sheet. It's on Google Classroom. Um, we have different forms in this test. What is the word form? Form simply means the way an equation is organized, right? So if you have an equation that has your x's and y's on the left side and a number by itself on the right side, that's called standard form. If you have y by itself, that's called function form, having y by itself, but it's also called slope-intercept form. Function form and slope-intercept form are the same thing. They both have y by themselves, but understanding slope-intercept form will help you graph because there's more details than just having y by itself. The number in front of x, the fraction in front of x is a slope, and the b value is the y-intercept, okay? So let's go back to standard form. What the heck is standard form? Again, ax plus by equals c. A, b, and c are just integers. They're numbers. They could be positive or negative. No fractions, no decimals, right? So if you do have x's and y's on the left side and the number by itself on the right side, no fractions, no decimals, it's really easy to find the x and y intercepts, okay? What the heck are the x and y intercepts? It's where your line will cross the x-axis and where it crosses the y-axis. Just with those 2 points, you could draw your line. Okay, now how do you find the x and y intercepts? Well, to find the x-intercept, you set y equal to 0 and solve. To find the y-intercept, you set x equal to 0 and solve. I apologize, a lot of you already know how to do this. You might be bored right now. But here's an example. That is in standard form. Your a value is -3, your b value is 4, your c value is 12. The x and y terms are on the left side, right? The number by itself on the right side. So when you have it in this form, it's really easy to find the x-intercept and the y-intercept, okay? I could just look at it, and I know that my x-intercept is at -4, okay? How do I know that? Because to find the x-intercept, you set y equal to 0 and solve. To find the y-intercept, you set x equal to 0 and solve, right? So I already know my x-intercept is at -4 because if I set y equal to 0, that's going to disappear. And it's like if I have a simple equation right here, one-step equation, divide by -3, divide by -3, x will equal -4. So my x-intercept is at -4. That's my x-intercept. For my y-intercept, you set x equal to 0. So here's x. Just cover that up now. And now it looks like a simple one-step equation that reads 4y equals 12. So my y-intercept is what? 3, okay? So just by knowing those two things, you could graph your equation, your line. Of course, during the test, I recommend you show your work. I want to see your work. So to find the x-intercept, you set y equal to 0. So I would like you to rewrite this, but instead of y, put 0. So you have a -3x plus 4y equals 12. Put a 0 right there, okay? And same thing for the y-intercept, set x equal to 0. So you rewrite it, but instead of x, you put 0. So -3 times x, but instead of x, you put 0. And then plus 4y equals 12, okay? And then you solve both of them. So you're going to get -3x equals 12. Then you divide by -3, divide by -3. And you get x equals -4, what we already had before, right? So you could do this easily in your head without showing the work, but on the test, I would like you to show your work. On the other one, 3 times 0 is 0. Divide by 4, divide by 4. You get y equals 3. There's your answer, 3. Now keep in mind, these are intercepts. So the actual location of the x-intercept will be, since you set y equal to 0, you're going to have a 0 on the y, and you found out that x was -4, so your x value is -4. So the actual location is -4, 0, and on the y-intercept, you set x equal to 0, and the y value was 3, so your coordinate is 0, 3 for the y-intercept. It's that easy. So there will be questions where I give you an equation and I say, find the x-intercept. Oh, that would just be -4, 0. Or I could give you that equation and just say, just find the y-intercept. Oh, that's 0, 3. Or I could give you the equation and tell you graph it. Now, if you're graphing this, well, yeah, you find both, where it crosses the x, where it crosses the y. And then from there, it's really easy. All you have to do is go to your graph, go to the x-axis, go to the x-intercept at -4, -1, -2, -3, -4, put a dot right there. Go to the y-axis, that's the one that goes up and down. Go to the y-intercept at 3. So that's at 1, 2, 3, put a dot right there. And then, of course, all you need is 2 dots to make your line. There, you graphed it. So if they tell you to graph a standard form equation, find the x-intercept, put the point on the x-axis. Find the y-intercept, put the point on the y-axis. Draw your line. You're done. Cool? Now, you don't have to graph a standard form by finding the x and y-intercepts. You could choose to get that y by itself. Like you could get rid of the minus 3x by adding 3x and adding 3x. You could get y by itself and make it look like this up here, y equals mx plus b. As a matter of fact, let me write down that same equation up here. We have negative 3x plus 4y equals 12. And if I wanted to graph it, but using slope-intercept form instead of the x and y intercepts the way we did down there, well, we need to get y by itself. Again, form is just the way it's organized, the way it looks. So we need to get rid of that minus 3x by adding 3x. And what you do to one side, do to the other. You're going to end up with 4y equaling, let's write our x term first because you want the x term first before the number at the end. So we're going to put our 3x first. That is a positive 3x. And then the plus 12 because it's a positive 12 second. All we need to do now is divide by 4 to get rid of the multiplication of 4 in front of the y. Divide by 4, divide by 4, divide by 4, and we will have y equals 3 divided by 4 with an x on the side plus 3 because 12 divided by 4 is 3. So here's your y equals mx plus b equation. So if you have it in this form where y is by itself, the number in front of x is your slope, okay? And the slope is rise over run. As a matter of fact, if we read through this cheat sheet, b is the y-intercept, so the 3 is the y-intercept. That's where it's going to cross the y-axis. M is the slope, so the m in front of x, that's the slope, okay? And if you keep reading, m is rise over run. So it's a fraction, rise over run. So the rise is 3, the run is 4. If the fraction is positive, it will rise up. That's a positive fraction, so it's going to go up 3. If the fraction is negative, then it will drop down. Oh, typo, I put it, the fraction. It should be if the fraction is negative, it will drop down. So if you had a negative 3/4, then instead of going up 3, you'd actually be going down 3. Okay, so anyways, how do we graph using this form? To graph an equation in y equals mx plus b form, put a dot on the y-axis according to the b value. So you're going to put a dot at 3 on the y. It's this simple. Let's actually do that. Put a dot at 1, 2, 3 on the y. And then from that point, you are going to rise and run. That's what it says. From that point, rise and run according to m. So from this red dot, you're going to rise 3 and run 4. So you rise 1, 2, 3, and you run 1, 2, 3, 4. So showing that right here, 1, 2, 3, 1, 2, 3, 4 would be over here. Más o menos, right? If I had graph paper, it would look nicer. But anyways, there's your graph. There's your line. So it's really easy to graph with y equals mx plus b. You could change any equation to y equals mx plus b, but to be honest with you, if it's set up like this in standard form, I'd rather just cover up set the y equal to 0, cover it up and get that x-intercept, and then set x equal to 0 and find the y-intercept. It's as easy as that. If we continue on here, the last part of these notes, oh wait, no, there's more to it. Up here, y equals mx plus b. So you know how to graph with y equals mx plus b? And there's something else down here. The m, we're responsible for knowing the slope formula. So if you are given 2 points of a line and they ask you to find the slope of that line, you must use the slope formula, okay? And I always say that when you use this formula, you gotta rewrite the formula with the division and the subtractions and leave the blank spots on the y2, y1, x2, x1. And realize that those coordinates that you're getting, those are x and y values, but the first x and y is x from your first point, y from your first point. The second one is x from your second point, y from your second point. And that's where you get these x1, y1, x2, y2 values. So when you rewrite the formula, I recommend rewriting it with the blank spot on each of the y2, y1, x2, x1, and then plug in your y2, which is -7 in this case, y1, which is +2 in this case, x2, which is 3, x1, which is -5. Then you do the math. A minus minus changes to plus plus. Up on top, you get a -9. On the bottom, you get a +8. That is your slope. M equals -9 over 8. What does that mean? That from one point to another, you would go down 9 units and to the right 8 units. Okay? By the way, you may need to use this formula to find a certain value, right? So they may give you the slope. They may give you, like, let's say the slope is 5. and then they give you two coordinates, but they tell you one of the numbers is R, and they may ask you to find that missing value R. I already made a video on that. Check it out if you don't remember that. Anyway, if we go way back to when we first started graphing, even before standard form or before slope-intercept form, we started with function form. Remember getting y by itself? It's kind of like a machine, like a function machine. For each input, there's one output. And this machine, in this particular example, I have y equals 2x plus 1. So if I put in a 5, if a 5 goes right into this machine, what does it come out as? Anybody awake? 11, thank you very much. If I put in a 10 into the machine, it comes out 21, that's right. So you guys get the idea. Let's do one more. What if I plugged in a negative 4 into the machine? Whoa, negative 4. And yeah, plug it in, you get a negative 7 coming out, okay? So where are we putting in these numbers? This negative 4 that I plugged it in, where did I plug it in? I plug it in into the x. That's why these numbers that I'm putting in, they're called inputs. Where do I actually put them in? I put them in the x's. That's why they're also called x values. And then the fancy word of these numbers that are going in, those are called domain values, which are the x values. So all these words mean the same thing. That's important. That vocab is going to come out on the test also. The answers that come out, those are called outputs. They're called y values because when you do plug in a 5 times 2 is 10 plus 1 is 11, it says y equals 11. So 11 is the output, but it's also the y value because it says y equals 11 once you plug in the 5 and do the math. Okay, so these values are called outputs, they're called y values, and the fancy word is range. So it's pretty obvious inputs are the numbers that go in. It's pretty obvious x values because they go into the x's. It's pretty obvious that the numbers that come out are called outputs. It's pretty obvious that the answers that we get that say y equals, those are y values. Domain and range are the only challenging ones that you have to put some effort to memorize, but it's as easy as this. Just like an x value alphabetically comes before a y value, the domain alphabetically comes before the range, okay? So I hope we have all of this stuff down. There's only one other thing that I could possibly think of. I may ask you to graph x equals 2, all right? And the best way to logically think of this is to go back to an XY table and think about what this equation is saying. It's saying that the x value has to be 2, right? It has to be 2. In other words, the x's, no matter what coordinates you're pulling out of there, the x values have to be 2. Now, there's no y values in this equation, which means that y could be whatever you want. So it could be like 0, it could be -3, it could be +4, whatever you want, right? And you're going to get a vertical line. Think about it. That's a coordinate. Look, watch. 2, 0 is a coordinate. 2, -3 is a coordinate. 2, 4 is a coordinate. So if you go to 2 on the x and 0 on the y, that's going to be the dot right there. If you go 2, -3, 2 on the x, -3 on the y, it's going to be a dot directly below it. If you go 2 on the x, 4 on the y, it's going to be a dot directly above it. So your line is a perfectly vertical line, okay? Anytime you have an equation that says x equals a number, it's going to be a vertical line, okay? Likewise, if I were to say y equals 5, that's not going to be vertical anymore. Now it's going to be horizontal, right? It's going to you go to y on the 5 and you draw a horizontal line right through it, side to side. Again, logically, if you think about an input-output table, all this says is that your y values have to be 5. It doesn't even have any x's. Who cares about x's? X could be whatever you want. It could be -2, 0, 3, whatever. And if you did go to -2, 5, you'd be on that green line. If you did go to 0, 5, you'd be on that green line. If you did go to 3, 5, you'd be on that green line, right? So that's about it. I hope that you guys, if you're not prepared yet, I hope that you get prepared tonight to get a good grade on the test tomorrow.